Hello everyone, welcome to a new episode of Golang Cafe, and today we are going to talk about the Go I/O reader interface. The I/O reader interface it's used everywhere basically in the Go standard library and in a lot of places where you have to deal with data. So it is very important and crucial that you master the use of the I/O reader interface and as well as the I/O writer and similar interfaces, which we're going to see in new episodes as well. And the I/O reader interface is the basics of, it's one of the simplest one, and is one of the basics where you when you start working with data and moving data around, especially when you see in a lot of places in the Go standard library. So the first thing we're going to do, we're just going to see the definition of the I/O reader interface, and you will see that it is very straightforward. So the first thing that we notice when you go into the Go doc I/O.reader is that the reader interface has just one method, and it is the read method. So the whole gist around the reader interface and the read method is that this method is defined on top of a stream of data, which can be, for example, a file, it can be a network connection, it can be a string itself as well, it can be anything really, any type of data you can think of. Most often than not, you will have a read method where you can read the data from this stream and copy the data into a byte slice that you define. As you can see, the read method accepts a byte slice, which is p here, it's called as p, and so the stream of data which underlies the read method will be copied into the byte slice that you pass into. It returns n, which is the number of successfully read bytes, and error returns an error as well. So whenever, for example, if you're reading a file, whenever there is no any more data in the file or any more data in the stream, really, generally speaking, then you will receive an io.eof, which is end of file type of error. So you know that in that specific scenario there is no more data to read. Or you could also receive other types of error, which are not really don't have anything to do with the EOF, but maybe there has been any other types of issues while reading the file. Yeah, so the basic gist of it, it's as you can see in the interface, it's very simple. It's very simple and basic. You just have one method. It accepts a byte slice where you can copy the data into and returns the number of successfully read bytes. Today we're going to see a couple of examples on how you can use the reader interface and how the reader interface is used in some of the most commonly known standard library packages of Go. One of the most common scenarios that you will see is the os.file. Whenever you open a file, there is this OS package, which is an abstraction on top of your operating system. So regardless of whether you are on Linux or macOS or Windows, you will have always the same method. You will have always the same behavior, which is an abstraction on top of your operating system. So, and here you will see that the file is in itself an implementation of the reader interface, I/O reader interface, because it has a read method which accepts a byte slice and returns a number of an integer that represents the number of successfully read bytes, and returns an error as well. So the file itself, the os.file itself, it is in itself an I/O reader, and you can see. And you can see it by just looking at the documentation and see Godoc on os.file.read, which is exactly the implementation that we have just seen. So let's just go through an example. And here I have a book, which is a text file. So it is a book that contains, I think, 100,000 lines or something. Yeah, it's 24,000 lines. What we're going to do now, we're going to attempt to read this book using the I/O reader interface, or more specifically, we are going to use the os.file, and we're going to use the read method to read the file. Obviously, there are different methods that you can use to read the file. You can read the file all in memory, or in this case, is a more efficient way to read the file, which you only read a certain number of bytes at a time in memory. So the first thing we do, we go into our program, and I will just create a function specifically because you're gonna see later on that we have different scenarios. So for each scenario, we create a different function. So this one is a file reader example. It's just a function, a void function, file reader. We call the file reader function. So we attempt to read the file, we attempt to open the file, os.open book.txt. We check for the error, usual stuff. We just panic. Obviously, if you're building production code, don't panic. Then we defer the closure of the file at the end of this method here. And then now it comes the whole logic around how you want to use the read method. So the first thing we want to do is to define our buffer. So the buffer is a key part in our program when we want to use the read method and the reader interface. Because we're gonna copy the data that is coming from the underlying stream of data, so from the file, into our buffer, and that's gonna be done by the read method. So we first need to define a buffer. And when we define a buffer, we use the make keyword, which defines a byte slice. And you also need to define a byte size. So in this case, I'm just going to define 10 as a byte size. You can define any size you want. And this size, it tells us that the read method is going to read up to 10 bytes of data each time we read from the stream. And obviously we need to read 10 bytes many times because the file that we're trying to read is much bigger than 10 bytes. So what is going to happen, we're going to have a for loop, and within the for loop we're attempting to read 10 bytes at a time, each loop, and we're printing the result. So we define the for loop, and then we call the read method, which, as we've seen before, it returns a number of successfully read bytes and an error. So the file is a reader, so has a read method, and we read into our buffer. The first thing we do, we check if there is an error, and the first error we check for is the EOF error, which means that there is no more data to read. The next step we do is, if there is not an io.eof error and the error is not nil, it means that there is some other error, which we don't know the nature of. But we just want to print the error and we want to break, so we want to stop. And then there is the last step, which is if we are read at least at least 1 byte, at least non-zero number of bytes, we attempt to read the number of bytes that we just read. So, and we print on a new line. So it's each time we print the 10 bytes and then we print a new line. So you will visually see how it is going to show in the output. So we print our buffer we only want to print up to n bytes. We don't want to print the whole buffer because sometimes the contents that you read is less than the size of the buffer. So let's say that our file is only 5 bytes long. Okay, the first time we read the file, what happens is that it's gonna read the 5 bytes into our buffer, but the buffer is a fixed size. So if we don't print only the first n bytes, only the first 5 bytes in this case, then what happens is that we're gonna print all 0 values or other values that may be in the buffer. So we want to make sure that we read only the first n bytes, which is gonna be returned by the read function, so it knows how many bytes there were in the file. And that's it really. So this is really that simple. Just read from the file into the buffer. You obviously need to define the buffer and the size of the buffer. You check if there is any error. Specifically, you want to check if you arrived at the end of the file, and you also want to check if the error is not nil. In this case, there may be some other issues, some other errors, and then you print the result. So, and now we import all the dependencies and we try to run it. As you see, we just printed the old book, which is 24,000 lines, but in this case we're printing 10 bytes at a time and then printing a new line. And you can visually see that, because if you go into the byte size and you say, okay, the buffer size, and you say, okay, from 10 I want to read 20 bytes at a time, what happens is that if you run it again, you will visually see that we are now we are rather reading more bytes each time and then looping through the file. So this is really how easy it is to read the file. So now what we want to do, I just want to demonstrate the fact that you will need to read only the number of bytes that are coming from the file. So I will specify here a smaller file, a small.txt file, and this file has only, I think, 5 bytes. So we're gonna see how that plays out. So what we're gonna do, we're just gonna print the raw bytes that we read each time, and we are not gonna truncate. We're not gonna truncate the buffer. We're just gonna print the buffer as is. So just gonna see the file. We're just gonna see the file. We open in binary format, because otherwise there is a new line attached to it if you open in another way. So this is just a file. It contains 4 characters. It contains A, B, C, and D. So the number of bytes here should be 4. And if you use a buffer of size 3, what happens is that the first step the buffer will be full. So you will have A, B, and C in the buffer. In the second step, what happens is that the read method of the file is gonna copy only D into the first position of the buffer. But it's not going to change the second and third position of the buffer, so you will still see B and C inside the buffer. Now you will just see it how it will play out. As you see here, we have the ASCII value of the characters. So 97 is A, 98 B and C, 99. That's the first step. So the buffer size is 3 bytes. We do the first step, we print the entire buffer, and we go on the next line. And as well, what we do in the second line, we attempt to read 3 bytes from the file, but the file only has got 1 byte left. So we read the 1 byte left, which is D, and is represented as a 100 as an ASCII character. And then we have the 98 and 99, which are the old values we just read in the previous step. But if we don't read up until n, which in this case, in the second step, n is going to be 1, the number of successfully read bytes, then what happens is that we're going to print just some extra data that is not really relevant to the contents of the file. So we're just going to read, this is all data. And that's why you should be careful when you use a buffer and when you use the read function. You always need to be careful of reading and printing the right number of bytes that you get from the file. Because now here buffer only represents the content of the file up until n, which is the number of successfully read bytes I've seen before. So this is the file example. There is another example which is quite simple, coming from the string package. So if you have a string, for example, you can convert this string into a stream of bytes, into an I/O reader, really. And this reader has the read method. So if you go into the strings.reader, you will see that you have the read method, which is exactly the IO.reader interface method that we've seen before in the previous interface, in the general interface, and in the file, the os.file. So this is yet another implementation of the IO reader interface. And you can directly see here at the beginning of the description of the documentation, you see a string reader implements the IO.reader and some other interfaces, which we are going to explore in the next episodes as well. But as you can see, the the IO.reader is kind of ubiquitous everywhere in the standard libraries whenever you want to work with data. So this is just yet another example of that. And we are going to write another scenario where we have a string, and we want to read data from this string as if it was a file, or if it is using effectively the IO reader interface and the read method. So what we want to do, we define the IO reader from a string, which can be done using the strings.newReader. So now this very short but interesting string, which will be read using the read method. And then we do exactly the same thing, because the S implements, as we've seen, implements the read method. So implements the reader interface. So we define a buffer, as we've seen before. We define a buffer, make byte. In this case, I just want to read 1 byte at a time, and we go through all the bytes that the reader has got. So this reader is S. We read into our buffer. If the error is io.eof, it means that there is no more data. We just break. If the error is not nil, it means that there was some other error. We just want to see what the error is, and we break. And then we do exactly the same thing as we done before. If the number of successfully read bytes, which is n, is greater than 0, then we print the result of buff up until n. In this case, you don't really need that because the buffer size is 1, so yeah, you don't really need that really. But if it was 2, for example, you would need that because there may only be 1 byte at the last step or at any step, and so you would be reading the wrong data. So now we have exactly the same thing. So we have string reader, and we just want to test it. Go run reader. As you can see, we are just reading the string that we have defined, and reading 2 characters at a time, so using 2 bytes as a buffer. So a very short but interesting string, as you can see here, split by new line. So this is just yet another example of the reader interface. Now is the last one. The last one is also very interesting because it has nothing to do with files, or at least not in the sense that you may think of. But the last one that we've seen is the net.connection. So whenever you create a new connection, you can read the data from the connection, because you have to think of, from an operating system standpoint, the connection is just a file. So you read the data from a connection, it's just like if it is a file. So you read the connection from a socket, which effectively it is a file. So you can use the same behavior as you have seen in the iOS.file and the string reader example as well. So if you go in the net.connection.read, you will see that read reads data from the connection. Read can be made to time out and return an error after a fixed time limit, set that line, set read that line. So this is specifically aimed at the net.connection scenario. So the read method will return an error specifically in case the timeout was reached, or there may be some other errors due to the network connection. But the underlying interface, so the interface, it is exactly the same as we've seen in the file example, in the string example. Just the underlying implementation and the errors and the cause of the errors may be different because we are dealing with a network connection in this case. So the underlying, the underlying behavior and what's going on under the hood may be different, but the interface, the abstraction on top of that, is exactly the same. So we can just go and implement a network reader as well. We'll see how easy that is as well as the other example. Network, more like connection reader really, because it's reading from a connection. So we create the connection, which is net.dial. Dial wants the protocol and then wants the address, including the port. And then if the error is not nil, as everything, we just in this case we panic just for brevity. And then it's exactly the same as we have done with the file. Obviously here we will need to remember to close the connection. And now we just define our buffer as we've done before, so it's exactly the same pattern. You just need to remember and bear this pattern in mind. So we have the buffer, we make the byte slice, we define as you wish the number of bytes you want to read each time. Let's say I want to read 5 bytes at a time, and then we loop through the connection, we loop through the reader, and we attempt to read as many 5 bytes slices as we can. So we have connection, and we read from the connection into the buffer. If the error is EOF, it means there is no more data. We just break, we don't really need to print anything, or if you want to, you can. If the error is not nil, it means something went wrong, and we just we just print what went wrong, and then we break because we want to be stuck in a loop with the error. And then, as we've done before, we check whether there was any bytes read, and if so, we convert to string, and we read up until the number of bytes read. That's it, really. Like, it's what is like 10 lines, and that's a connection reader. So now we need to call the connection reader. We need to save, import the dependencies. It's the net, really is not much, and now we run it. Obviously, you'll need to specify a proper domain. Here it could be even an IP address and a port, so the DNS resolution is done automatically here, but let's see if there is anything that we have been missing here. We read it from the buffer. Yeah, seems like everything is fine. It's probably just timing out. Okay, there may be some other issue. So the connection, yep, because we need to obviously, once we open the connection, we need to issue a request. So we need to basically get HTTP, like a raw request. And this is the response as well. Let's go back to Google. Okay. As you can see, we're just calling Google, simple HTTP request. And we then reading from the connection, we're just reading 5 bytes at a time, as you can see here, and we print them out. Let's change that to be 25. As you can see now, you're reading 25 at a time. So yeah, so it is exactly the same behavior. So as you can see, the pattern is exactly the same, apart from the first few rows where each scenario has a different setup. So the reader and the stream of data is different. In this case, we have a connection, so the data is coming through the connection. In this case, just a string, so the stream of data is just a simple string. In this case, it is a file. So each scenario is different, although you can see here that there is a very similar pattern. And that's one exercise that I wanted to go through with you, which is basically abstracting out the I/O reader. And it is something that you can do in your programs as well. So once you know the underlying behavior of the reader interface, you can spot those patterns, and you can abstract out some of the code that you have in your program, and then you can make it more composable. Because imagine that this one was something that needed to be tested, or something that you had in your program, and you had all these pieces here. Then what you could do, you could basically just create a function that accepts an I/O reader, and then that function would work for the network connection, would work for the string reader, would work for the file reader as well. And when you have to test it, you don't have to create a connection to test it. You just need to send an I/O reader, something that implements an I/O reader. So you could send some fake data using a strings reader, for example. So let's just go through this exercise where we abstract out the reader to standard output. So what we're doing here effectively in the lines 64 to 77 and in the other lines as well, it is basically reading a fixed size byte slice each time into standard output. So what we want to do, we want to define a new function which we will call reader to standard output. And this function will take a reader, which implements IO reader, and a buffer size, which it will be different based on where it is used. And then it is exactly as we've done before. We define the buffer, so it's just basically what we've just seen before. The bytes buffer size in this case, so it's gonna be changing for all of that, and we're just gonna, for the sake of brevity, I'm just gonna copy all of that, and yes, so it is basically it. And here we change the reader to be R. And now what we do, we just change all of our implementation to follow to use this helper function reader to std out. In this case, it's a file, and we said that we want to read just 10 bytes, or like this one was 3 bytes at a time. Then we do the same here. This one was a string. This is reader to std out, and this takes the string as a reader and reads 2 bytes at a time. And the same for the network connection, which has a buffer size 25. So is a reader to std out, the connection is the reader, and the buffer size 25. As you can see, the result is exactly the same. And then we have abstracted out the code into a more abstract function that takes an I/O reader and a buffer size. Well, that was the reader interface. I hope you liked it, and see you at the next one. Thanks.